constant pressure calorimeter is used for finding the enthalpy of a particular reaction or the heat flow of a reaction. And normally these reactions in constant pressure calorimeters are going to be aqueous reactions. And this works by having a aqueous reaction take place in a material that doesn't absorb heat very readily. Normally a simple one can be made out of a styrofoam cup. Obviously ones that are more precise are made of different materials, but a styrofoam cup will work for very simple calculations. And in this cup goes a certain quantity of water that I measure out beforehand. The reaction takes place, and depending on if this reaction is an endothermic or exothermic reaction, the temperature of the water will change either up or down depending on what kind of reaction it is. Once I know what has happened to the temperature, I know how much heat has been given off by the reaction. That's the only thing that is going to cause the temperature to change. Once I know how much the temperature has changed, and I know the mass of the water, what I do is I look up the specific heat or the heat capacity of water, or of whatever I have in there. Normally water is the easiest. And the specific heat or the heat capacity is the ability of something to absorb heat. How much energy does it take to raise the temperature of something? And specific heat is a gram of the substance. There's molar heat capacity, which is how much heat does it take to raise a mole of it 1 degree centigrade. Specific heat capacity is grams. So what the specific heat capacity is the amount of joules or energy it takes to raise the temperature by 1 degree centigrade a gram of the substance. So if I have the mass of water ahead of time, I already have the mass, I look up the specific heat capacity, and then I measure the temperature. Once I have all of these things, I can figure out the total heat given off. Because mass, which will be measured in grams, and the delta T, which will be measured in degrees centigrade, are going to cancel out these units, and I'll be left with simply joules. And that is what will be my total enthalpy for the reaction.